Okay. Can you hear it?
Yeah.
Okay.
So everyone is I am audible to you. So
Yes.
good morning. Sorry for there is an internet issue from my side. I think because my Wi-Fi is not working in the morning, so I'm connecting with my cell phone. So we can begin like the problem which is shown on the screen. Maybe it's a similar problem which yesterday professor has given to you, but I twisted it a little bit. I made it as like an beam extended. A shaft has been extended to point A, and we put the bearing on B and G. There are two bearings, so it's like a shaft supported through the two bearings at B and G. One pulley is placed at C point in between the B and E, that is a CD in green color. Is I'm audible, Ila?
Yes. It's okay.
It's okay.
Yes.
So there is a point, the pulley between the B and point E. Maybe you can put little upwards, a PDF little upside,
Yeah.
or maybe yeah, you can just make the small. It's in a small size.
Oh
So
yeah.
that, yeah, okay, okay. Okay, that's all. That's all. I think first page only one page. So let them start writing the question. That's good. So there is a pulley between the point B and point E. So this is where the pulley has like a 2 distributed loads. That is W1 is 10 Newton per meter, and the W2 is of 8 Newton per meter. And there is another pulley at point in between of E and F, G, that is of green color, which has a distributed load of W3 and W4, which is equal to 12 Newton per meter along the y direction. The pulley here is along the x direction, and here is along the y direction. So there is a g direction and y direction. The load are acting on the two direction, and the central axis is in the x direction. So assuming the forces, reaction forces at, because the bearing supports this shaft, the bearing support this shaft, and the pulley are in between these two bearings, and the shaft is elongated till point A. So the reaction forces will be at point B and point G. There are two concentrated reaction forces. Ignoring the weight of the shaft of the bearings and pulleys, we are not considering the weight of the shaft of the bearings and pulleys, and the diameter of the shaft D is given as 35 mm, and the diameter of both the pulleys are 75 mm. So we have to determine first the reaction forces, shear moment diagrams, worst loading position, Morse circle of worst loading position, principal stresses and maximum shear stress at the worst loading position. Now everyone got the question? Is the question is clear to you?
Yes.
Okay. So write down the question and the first reaction forces. Maybe you can find the first reaction forces. Don't show Ila. Let them can start calculating. Then we will go step by step. So start calculating the reaction forces first. So the reaction forces will be like in both the direction. One in the y direction, you have to find the reaction forces, and another in the g direction. Maybe you can simplify it into the load diagram. Ila, can you move upstairs a little bit up? So you have to calculate first the reaction forces Gy, Fgy in the y direction. Then you have to calculate Fbz and Fdz in z direction. Anyone has calculated? Anyone has calculated?
No.
Does the diagram match the
So let's check.
Wait
Can we see?
Wait a second, please.
because like the first movie says and like
First, you have to calculate the reaction forces at the F.
Ready.
There are 4 reaction forces at the bearing.
Patel, please wait
Yeah.
a second. Yeah.
Okay. Let's you can calculate.
Professor,
Whenever you are ready,
Professor,
just tell me, check the answers.
Professor, may I ask you a question? Does the diagram match the the exercise explanation because the first pulley belt says that it's between B and E, and like in the diagram, it looks like it's between like the between C and D.
The pulley is between the C and D, where there is a W1 and W2 are the load on the pulley.
Yeah, this one. This one is between B and E.
This one
Okay.
is in the G direction. Yeah, here it is in the G direction.
Oh, this one.
There are two distributed loads. The one is with the G direction. And in this pulley, you have to consider the loads. Both are same 12 Newton per millimeter in the Y direction. So when you are calculating the reaction forces, if the force direction is in Y or G, you have to check when calculating in Y direction, you eliminate the G direction loads. Is it clear?
Sir, your internet is worse now. I cannot see the screen.
Okay.
It's okay now. Hello?
Yes.
Okay, it's okay now.
Is it okay?
Yes.
So when everyone will be calculating the reaction forces, let me know.
No, sir. Can you continue?
Everyone calculated the reaction forces?
他要你们先解题。有人解出来吗？
Okay, let's check how to calculate it. Let me. Everyone is getting this slide. So here the W1 load is almost 10 Newton per meter given in the question. W2 load is 8 Newton per millimeter, which is also given in the question for the pulley 1. And where for considering the pulley EF, W3 equals to W4 equals to 12 Newton per meter, which the load acts in the Y direction. The shaft diameter is 30 mm. The pulley's diameter is 75 mm. This is the question given in the question. So let's first consider the calculation of reaction forces. So summation of all the reaction forces in y direction. So there will be the force acting on the bearing B, that is force at By, plus force acting on the G in y direction is equal to W3 plus W4 into 20. Because it is acting in upward, we create it as a negative. So it will be, total will be 480 Newton. Then we consider the movement about A, the end point. Let's summation of all the movements about end point equal to 0. Then force from By into total distance. So we are taking the moment about G. So the force is acting in direction. The total distance from here, it's acting on the center of this point. So 10 divided by 2 is 5 plus 40 plus 20 plus 80. Now this is 20 and 50 and 10. So it will be like total distance till the end point, till this point, plus the load acting on the y direction is W3 and W4. The load acting on the y direction is W3 and W4 into the total pulley have a distance of 20 mm. So it will be into 20. It's like an load because it's a distributed load. So we have to make it as a concentrated load. So the total force into distance, that will be W3 plus W4 into 20 into the center point till last distance. So it's 10, 20 divided by 2 because the load is acting at the center, and plus 50 plus we have to calculate load till movement till here. So plus 10 by 2, 5. So the total reaction forces FBY and FGY is calculated as 141.82 and 338.18. Have everyone calculated? Is the answer is same for everyone?
Yes.
Okay, good. Then calculate in the G direction. Similarly, calculate in the G direction. So it's like FBG plus FGZ plus weight, both the sides, weight W1 plus W2 into 20 because it's a distributed load. So FBZ plus FGZ equals to minus 360. Then take the moment about again about the BZ equals to 0. Now we are considering the moment about G. So W1 plus W2 into 20 into 10 into 40 into 5 because we are considering the moment about BZ. Here it's GY plus force acting on the FGZ. From this force to this distance is 5 plus 50 plus 20 plus 80 plus 20 plus 40 plus 50. So the forces are FBZ equals to minus 90 and minus 270 Newton. Everyone got this reaction forces?
Yes.
Okay. So let's move to the next point. The first answer you already got is the reaction forces. Then we have to find out the shear moment for the shear and bending moment diagrams. So now let's simplify it. So like professor is calculating through a continuously taking X and calculating throughout the beam. I taught you in a simple manner how we can treat it in a simple manner. So first you have to make a shear force in Y direction. So you have to calculate the shear force in Y direction. So make that your beam is a simple line. Make it as a load diagram. So it's in the Y. It's a point A, point B, where this force in Y, we are calculating the shear force in Y direction. So the force acting in the Y direction is force By, acting upwards. As C, it's D. Actually, we are treating that it's supporting the load. Maybe it's from any side. From E to F, in the Y direction, we are getting W3 and W4. So W3 and W4 is like total load will be 24 because it's 12 plus 12. We already know that W3 equals to W4 equals to 12 Newton. So we consider it as a 24. And here FGY. So this is a simplified diagram for shear force calculation in Y direction. So already you know that FBY, reaction forces, already you find out. FBY is minus 141.82. Okay, let's draw the shear force diagram. I will not let you know. First, you can draw the shear force diagram. So, okay, let me start from here. So I'm starting from right side to the left side. Okay, so right side to the left side. So we are starting from the G point. So all the, I think it's reverse. So load beyond this G is 0. So when we start from here, the load beyond this G is 0. And the load FGY is acting on the center. So from load, already we calculated the load FGY. So it's 338.15 and it is in positive direction. So it will be like somewhat here. Then we calculate the load at F. So F will be your 338 here in the F point. And 24 into 24 is the total load at here. And 20 is it. Actually, it's not F, it's in the E point. it will be at this point, and you will get minus 142.82 Newton. So here, this inclined line will be, or the elevating graph will be in the downfall, where we can understand the reference point at point O, maybe the shear force will be 0. So this O point is very crucial because it have maximum bending moment at this O. Where the shear force is 0, the bending moment will be the maximum. So why we are calculating a little left or right is because force is changing. So any point at C, D, and B, the shear force will be the same because there is no load in the y direction. Then at point B, again we'll apply the shear force. It is just before, that is minus 1. So from 0 it will start to 338. It will be same till point F. Then there will be a sudden change due to the pulley of EF. It will go to the minus 141.82, and it will be the same and go to the 0. So whenever we start from the A point, it will be start from 0 in the similar way. Have got this diagram, everyone? Have you understand this diagram? Have you drawn the shear force diagram? Is I audible? Actually, we have simplified this beam problem into a simple load diagram, the force diagram, which I am showing here, like A, B, C, D, E, N, X. I simplify the above beam diagram into a simple load diagram. Then we calculated the shear force at every points, and we just draw a simple line diagram for the shear force. Is it clear?
Yes.
Okay. So everyone got this shear force diagram? Now, how to calculate the point where this shear force changes its sign or it becomes the 0? So in this shear force diagram, we can know that at point O, the shear force changes its sign from positive to negative. So this point is considered as the maximum bending moment point, particularly in y direction. So this point O is the point where the shear force is 0. So the bending moment at 0 will be the maximum between E and F. So in here, the bending moment will be the maximum. So what I am doing is like I'm making it very simple. So we are applying similar triangle rule. So here that is like 141.82. I consider these distance as x. From E, the distance is x. So from F, the distance will be 20 minus x. So now with the similar triangle rule, the point is 141.82 at this point, divide by x. So we can see that there are two similar triangles. So this distance by this x is equal to this distance by this 20 minus x. So in this way, we can find out the x value as 5.91 millimeter. Therefore, from here, from F point is 20 minus x, that is 14.09 mm. So in this way, we can calculate the point at which the shear force is 0 and the bending moment is maximum. Are you getting this point? How to calculate the point O? Everyone got it? How to calculate the point O? Or I repeat.
We got it.
Okay. So let's move on to the calculation of bending moment in y direction. Let's I see I have drawn the shear force or diagram already, and when there is a at point O, the bending moment will be maximum. So first start from any side. If you want, you can start from A side, or you want, you can start from G side. So suppose I have started from G side. The bending moment at G, at point G, is always 0 because it's the end point. There is no load at the end point. Let's consider the bending moment at point F. So point F. So there will be the force into, oh, this is a multiplied, into the distance. So the force acting at G and the distance till F. So the force at G and distance till F will be somewhat minus 338.18 into 50 plus 5. So you will get 18.56 into 10 power 3 Newton meter. So in similar way, calculate the bending moment at point O, point E, D, and B. So now everyone calculates this bending moment. Then I will check it. Let's calculate the bending moment at point G, F, D, E, B, and B. Is it done?
Yes.
Have you drawn the bending moment diagram?
Yes.
Yeah. Okay, we can cross check. Wait a minute, I'm writing one more question. Okay, now you can check the bending moment at point G is 0. Now the bending moment at point F is minus 18.56 into 10 power 3 Newton meter at this point. Then bending moment at point O. Already we calculate the distance of O from the any of the side like F or E. So bending moment at point O is, we can calculate through the distance what we calculate from similar triangles. So you will get 20.98 into 10 power 3 Newton millimeter. And then bending moment at point C, we have to calculate 9.219. Then the bending moment, actually it is in the center. I have made some mistake. This will be in the center at point D. Then bending moment at B will be 0. So everyone got this diagram? So there will be the maximum bending moment in Y direction will be at point O, where the shear force will be 0. So the maximum bending moment will be minus 20.98 into 10 power 3. So did you get this? The maximum, wherever there is the shear force will change the sign or it's 0, the bending moment will be the maximum. Everyone got the same values?
Yes.
So now all of you calculate the similarly bending moment and shear force diagram in Z direction. I will not show you. You do yourself. Calculate the bending moment and shear force diagram in Z direction. Just I will show you the glimpse like in Z direction. You have to calculate the bending moment and shear force diagram in Z direction. Is it clear?
Yes.
Okay. Thank you.
Yes.较小，因为有分数，
对，这有分。
但是在哪里教？
之后会开表的。
哦，不用直接这里教，用
Similarly, everyone calculate in G
配后
direction.
调，配后配比较好。
You can make a simple diagram.
OK。
When you are calculating in G direction, you have to consider the pulley at you are calculating in the G direction, you have to consider the pulley CD. So now you have to find out another point P on in between the C and D, because here the shear force will change its direction.
It's okay now. Let's move on.
Can we move on?
No.
Let's check the answers. Everyone got this diagram with this value? So now you have to calculate the point P distance, because in the P we can know that it's the point where the shear force is 0 and the bending moment at the P will be maximum in between of C and D. So by applying similar triangle rule, is C and D is wrongly stated as C and D. So by applying similar triangle rule, so 270 divided by 20 minus y, where there we have considered x, so we have changed the symbols as y here. So 90 divided by y. So here the y distance is from the D point is we get as a 5 mm. So from D at this point will be your at 5 mm will be the maximum bending moment, and the shear force will be 0. So check the answers for bending moment at Z direction. Everyone check your answers for the bending moment for the G direction.
Yes. Okay.
Have you got the same answers? We are calculating again the moment at, actually this is P, moment at P, not O, is the P. So we are calculating again at G, D,
Yes.
O, C, and B. Because here there is no load in between of D and G. So we are not calculating any point at this point because it will be the same. So we are just calculating it here. Did you got the same answers?
Yes.
Okay, that's good. So can we move to the next part? So now these 2 points are clear. The reaction forces we have to calculate initially. Then we have gone for shear and bending moment diagrams in both the direction, that is Y and G, because the load are acting on both the directions. So these two questions in the problem has been solved. Also, we have find out the point at which the bending moment is maximum, and this both the question given. So now the problem is, like whenever we are calculating the in the G direction, there is also influence of load on Y direction towards it. So we have to calculate at the point, suppose we have to calculate at the O point, this O point, the influence of G direction, the maximum bending moment at O point due to the in the G direction, and we have to calculate the again at this point P, the maximum bending moment at P for Y direction. Is I'm clear?
Yes.
As there are 2 points, so we have to calculate 2 maximum bending moment points. So because the pulley in different directions can influence in either of the different directions of Y and Z. So from the bending moment direction in Y and Z, when we are calculating X equals to 5.91, that is in Y direction, so the distance from point O from A. So I'm calculating every distance, bending maximum moment point distance from O and A. So we know that the O is here somewhere between the pulley E and F. In between the pulley E and F. So the distance from O to A is your 205.91 mm. So when there is like it's in the when there is a in P direction, when we are considering the point P in Z direction, so the distance from point P from A will be 115 mm. So now I calculate all the movement, maximum movement through these two values of OA and PA. So the maximum bending moment at OA, that is 205.91 in Y direction, will be minus 20.98 point O. So the maximum bending moment at point O will be minus 20.98. So from the end, from the A point to O point, already we calculated this bending moment. So no need to calculate it again. So the maximum bending moment of OA from the A point is here. In Y direction is already calculated. But what about the influence of G direction? The forces acting on G direction on this point. So we have to calculate the bending moment at point OA, that is point O in G direction. So let's start from the A. So it's minus 270 into the distance from BZ, F of BZ till point O into 18, because we know that W3 and W4 are W and W2 are the same, is 18 in the Z direction. 18 into total distance is 20 into the total distance from these pulley, the load acting on the pulley, till the point O. So we have to find out the maximum bending moment at point O in G direction. Is that clear? See, we are calculating, again I am stating you that we are calculating at point O, at point O, but not for the Y direction. We are calculating at point O for the G direction. This point, the bending moment at point O for the G direction. So this is the calculation. Is everyone clear?
Yes.
Okay. So the next part again at P, the point P, which is at a distance from A, that is 115 mm. So now at point P in G direction, already you have calculated minus 114.175 here. At point P, already you have calculated minus 14.175 at point P. So no need to calculate it again, just write down. But what is the influence of point P on Y direction? So Y direction loads on point P. So we have to calculate again maximum bending moment at point P, but in Y direction. So this is the calculation. So everyone calculate it and check that answers are same.
Yes.
Okay. If the answers are same, now what we have to do is we have to make a resultant movement at point O. Calculate the resultant movement. So we have to calculate the resultant movement at point O. So now it's under root of both the values, square of both the values. Calculate the resultant moment at point O and point P separately. We are doing this because we want the maximum bending moment of whole shaft. So where there is a maximum bending moment. So we are calculating on taking all the considerations of Y and Z. So forces acting on Y, influence on Z, and forces acting on Z, influence on Y. So now take the resultant moment. So resultant moment will be your both the values. So you get like 20.98 under square under root and 6.212181 square under root. So this will be a resultant moment at point O, and this will be the resultant moment at point P. So now what we have to do is like we have to check the resultant movement. Whichever movement is of higher value, we will consider the net maximum movement as the value of which is higher. So here we can see that at point O, the resultant movement is higher. So we will consider that the distance from point A, that is 205.91 mm, is your maximum, the point at which there is a maximum bending moment. So this is the calculation for the point at which there is a maximum bending moment. So this point is considered as the maximum bending moment point. So your O point is your maximum bending moment point in this problem. So just consider which is the higher value. So everyone got this answer? So now we are considering that the O point is your point at which it is having maximum bending moment. So this point is at a distance of 205.91 mm from A. Did you got this?
Yes.
Okay. So now the next part is, see, we have calculated already. We know that which point is the maximum point of worst loading or the maximum bending moment. Already given in the question that point, you have to find out worst loading position. So already we find out the worst loading position as worst loading position is 205.91 mm. Okay. So next we have to find out the torsion at O. the torsion at this worst loading position. So it's your 2 into 20 into 75 by 2. Already the diameter of the shaft is 1500 Newton millimeter. Movement at this point already we know is 21.88 into 10 to the power 3 Newton millimeter, the maximum movement at point O. Therefore, you have to find out the stress as this point. So the stress as point by the formula 32.m pi d cube. Already in the last to last lecture, professor told you about how to calculate this stress, finding the stress formula. Just put the values on this formula. You'll get the sigma value as 5.198 Newton per millimeter. Everyone calculate it.
Professor, for the torsion, aren't we multiplying the net weight, like the net force, W3 and W4? So shouldn't it be zero because W3
Any question?
W4. Hello, Professor, can you hear me?
I'm not able to. Or
Hello,
did
sir.
anyone have any? Yeah,
Can you hear me?
yeah.
For the torsion formula, I thought we were multiplying W net with the 20, right? So if W3 equals to W4, why is it still 2? Because Professor Lin mentioned that the equation for T torsion is the net, which is, W3 minus W4, but they're the same, right? So shouldn't the torsion be 0 at that point?
You are telling that we have calculated W3 and W4 is same value.
Yes, like that's given, right? W3 is 12 and W4 is also 12, right? Like in
No,
the,
it will be not be like because it's in the y direction. See, W3 minus W4 it's to 0. I could not got your point actually. In the last class, professor told something different.
yeah, like in Professor Lin's lecture, he mentioned that the torsion formula is the net.
Oh, torsion formula. Let me check what he has.
Like I think for the example last time, we had I think W1 equals to 17 and W2 equals to 15. And he said that the net would.
You have different values of W.
Yeah, I think we have different values here.
But in this problem, if there is the same value,
So yeah, so why is it still 2 times 20? Because shouldn't it be?
我会开一个上课大全。
我下个礼拜见。
just a minute, I will check. Let me check.
This time I think it's the same. Yeah, I would think both of that.
Torsion at point O, 2 into 10. Let's consider its torsion at O, and then the moment at maximum moment at M equals to 0. So we'll have a stress at like sigma value, tau value. Then consider tau max as sigma A minus sigma B whole square. So we know that the is 0. We just put the sigma A value. We got only one value. So find out the tau max and the principal stresses at both. So we know that the principal stress at 2 will be almost equal to 0, negligible, like 1 into 10 power minus 3. So we consider it as 0. So kindly calculate this one. I will get back to you how you can calculate the torsion at O.
What? 等一下。哦。 Sir, the class will end in 5 minutes.
Yeah, it's okay.
Oh, it's okay. Okay.
So now you calculated this one. So actually see the torsion at 2 is like, because we are having two pulleys. The two pulleys, that's why 2 into the total width of the area, like here 20 and 20, into the diameter of the pulley is already given. So it's like a 75 by 2. So we are considering this as a total as a 1500. And the moment already we calculated as 21.88. So therefore the stress at particular point O, the worst loading point, will be 32 m by PD cube, where m is your moment. So you got like stress at 5.198 Newton per millimeter square. And when we consider as a tau is 16 into T, you already be calculated from here, upon pi d cube. So it will be 0.178 Newton per meter square. So you got the sigma and tau value, the shear stress and stress, normal stress. Now your tau max will be your sigma plus tau a square. Here the b value is almost 0. So you will calculate that 0.5198 square divided by 2 plus 0.178 square. So you'll get the tau max maximum shear stress as 2.6 Newton per millimeter square. So now you calculate the principal stresses. There is a maximum shear stress and principal stresses, as you already know the formula of principal stresses. So the principal stresses S1 and S2. So you can check the slides I am sharing you as the professor slides. The principal stresses S1 and S2 and maximum shear stress. We know that the sigma A and sigma B whole square by 4 plus tau A square. Here sigma A plus sigma by 2 into this value. This is actually the tau max. This whole we can term as a tau max. And S1 is already sigma A by 2 because sigma B is 0. And in S2, similar way, it's a minus of these things. So we have calculated S1 as 5.198 by 2 plus tau max value, and we got 5.2 as the first principal stress. Is when we check that it's similar to the maximum bending stress or the normal stress, means the value is same, almost similar, and the principal stress S2 is almost equals to 0. So now we can consider the tau max S1 and S2 and draw the Morse circle diagram. So everyone kindly draw the Morse circle diagram. Is it clear?
Yes.
Okay. So I will share this problem slides to Ela. He will share to you. I will make some corrections in this. Maybe whether I have some point notation is wrongly stated. So I will correct and just share a new one.
Okay.
And again, I will share you one more problem. Maybe you can note it down. Just I am sharing you.
Okay. Okay, thank you, sir.
I'm sharing you one more problem. Just note it down. It's a simple problem. It's not a 3D problem, so it's a very simple problem. Can you able to see the problem?
Yes.
Yeah, there are the two fixed support making in brown, and there are three pulleys having a load of, like in one direction, 360, 500 and 160. So now you have to calculate the reaction forces at both the support. Calculate the reaction forces at both the support. Also draw the shear force and bending moment diagram. I think you can find out all the values with the same, like shear force, worst loading position, Morse circle for the worst loading position, and the principal stresses and maximum shear stress.
But we don't have the diameter of the pulley.
Yeah,
We need the diameter.
the diameter of the problem. Wait. Because this now I have. make the diameter of the shaft as 40 mm.
And the pulley?
40 mm. And the anything else?
The pulley of the diameter of the pulleys.
Oh, the diameter of the pulley.
Yes.
Consider the diameter of the pulley as 80 mm. This we can make it double.
Sir, the time is end.
Okay,
Over.
okay. Thank you very much. If any questions, let me know in the Facebook group, I think.
Okay.
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 I will share these slides to you. Ila, you can just share to everyone. Okay.
Okay.
Yeah. I'll make it small mistakes are there so I can correct it. Yeah.
Okay. Thank you, sir.
Thank you. Thank you.
Okay.
Okay.